Hello, good people. Today I'm going to show you one possible way how to manage the full life cycle of your applications from beginning to the end. Now, in the description, I promised that I will start from the very beginning, meaning creating the cluster, but then I realized that it takes a bit of time to do that. Simply takes around 10-15 minutes to create the full operating cluster, so I skip that. I have already cluster, but I will show you everything else. How to manage full life cycle of your applications. Now, quick introduction for those of you who haven't seen me before, haven't heard me before, haven't met me before. My name is Victor, and I'm a principal DevOps architect, I think, something like that. Anyways, what matters really is that I work for Codefresh. Codefresh is a cool company, that's why I work there. Go to codefresh.io, check out now, later. Don't do it now. Listen to me right now. Go to codefresh.io after this session. My tweet handle is somewhere there. I don't know. You will find it if you want to get in touch with me later. It's at vfarsik. And what else? Yes, before we proceed, you are right now watching this on Codefresh YouTube channel or somewhere else. I don't know. It could be in different places. But if you're on YouTube or wherever else, click the subscribe button. I will be posting increased number of videos over there. So, or other people will be doing the same thing. So subscribe, and then you get notifications when we do cool stuff, including me. Okay, so that's the formalities now that they're out of the way. Let's talk about what we are really going to do. Now, I will show you one possible way to do the life cycle of your applications, and I will base that on two important things. I will assume that you want to do continuous delivery. And by continuous delivery, I mean automating everything except pushing changes to Git and merging changes from one branch to another and what's not, right? So Git operations are manual. Everything else, absolutely everything else, fully automated. Now today I will focus on mostly on the deployment part of the process. I will skip running tests. You will just have to use your imagination that I'm executing run unit tests, run functional tests. Focus is mostly on the deployment part of continuous delivery. And everything I do will be based on GitOps principles, and that is very important. That means that there will be nothing. I will not click any buttons. I will not do any such thing except to show you stuff, only to show you stuff, not as part of the process. And everything I do, absolutely everything, will be defined as Git. There will be no ad hoc changes in a cluster or anywhere else. So Git-based approach to continuous delivery. And by GitOps, sorry, am I saying Git? GitOps based approach to continuous delivery. And what I mean by that is the very simple definition of GitOps, and that is that everything is defined as code. Code lives in Git. Git is the source of the truth, or to be more precise, the source of the desired state of something. And process is running somewhere, wherever that somewhere is, and we're going to get to that part, have a job to converge the actual state, what is happening in our cluster, into the desired state, into what we want to have as the end result, as the end state. So, continuous delivery with GitOps. Now, let me switch the camera very quickly. What we are going to do, actually that's the wrong camera, this camera, so what I'm going to do, let me draw you very quickly the whole idea, and we're going to have a cluster, in this case based on Kubernetes. Everything I'm doing could be in multiple clusters, but for simplicity, I will have one cluster and everything will be happening there. That's the actual state. This is I will not be able to access the cluster in any form of way. Actually, I will access the cluster, but only as a way to show you how things work. But you need to imagine that I don't have access to the cluster because, as you will see soon, I don't need access to the cluster. So what I do have access to are Git repositories. So I will have some repositories of some applications. Application. And that's where code of my apps is. So I will be making pull requests today, always pull requests. So I will make pull request to make some changes to my application. And I have a certain requirement when I create pull requests, and that is that every pull request needs to be built, needs to be tested, needs to be this and that. And for many of those things, for me to do, creation of pull request means that my application needs to be deployed somewhere inside of the cluster. In this case, it's Kubernetes as a pod. So if I create a second pull request, I will need that deployed as well. And if I make a pull request to some different application, I will need that deployed as well. So I need to have as many versions of my application or applications deployed as there are pull requests, because it's very important, at least for me, that I don't need to wait for anybody to do anything. And that means that I cannot really use the traditional way of approaching things. I cannot have, let's say, development environment or staging environment, because if I deploy everything to a staging environment or a testing environment, then I cannot have 5 or 500 or 5,000 or 1 pull request in parallel, right? So every time I create a pull request, that needs to be tested, built, this and that. And that means that every single pull request needs to be deployed somewhere in some unique space without really conflicting with anything else in that cluster or any other cluster. So that means that when I create a pull request, I will be using Codefresh today. Codefresh. And whenever I create a pull request, it will notify Codefresh. All those pull requests will notify Codefresh. Codefresh runs continuous delivery pipelines, and it will run pipelines that will do what needs to be done. And now I need to go back to my initial statement. I don't have access to the cluster, but I will also not give Codefresh access to my cluster. Codefresh also cannot access to my cluster. Nobody can access my cluster and change the state in it. What that means is that those pipelines here, that will be pipeline builds, that will be running in Codefresh, need to build my binaries, build container images, do this, do that, and when the time comes for applications to be deployed, that pipeline will need to change the definition of what my cluster is in a Git repo. So, as such, I will have Git repositories that I will call environment repositories. Those will be the repositories that define the desired state. This is desired state, and this is actual state. So this repository will define what should be running here in the cluster. And that means that whenever, assuming that everything is fully automated, those pipelines, when I create pull requests, should be modifying my Git repository that defines my environments. And then we will have some entity in the cluster, and in this case it will be Argo CD, that will be pulling those repositories and converging whatever is defined here into what is the actual state. Once I'm finished working on a pull request, I do not want things to continue running. So whenever I close pull request, I want to save money, right? If I close a pull request, this deployment will need to be removed. If I close this pull request, this deployment will need to be removed so that only the things related to open pull requests are running in a cluster. And finally, when I merge pull request to the master branch, I will assume that that's a signal, that's approval for that feature, for that change to go to production. And then that will trigger pipelines again, and those pipelines will modify environment repositories, and Argo CD will modify my production environment in this case. It could be staging environment, it could be anything else. Now, I'm pretty sure some of you got confused. That's okay, because I'm going to show you all that in practice, and you will see soon how all that really looks like. So, let's get going. Let me show you how to do all that. Let me see if there are any questions. I see the Anais, thank you so much. Anais is answering the questions for me. I see the Solkin is asking, what is the fastest way to set up my first Kubernetes cluster? Solkin, you can, if you want to try things out, you can run a local cluster with Minikube, with Kind, with Docker Desktop, or you can run it in cloud. It's very easy to set up a cluster kind of for practice purposes. Let's say Google or AWS or Azure, they all have managed Kubernetes solutions. So local or cloud, they're all very, very easy. Now, I will post a link later. I wrote an article that describes how to set up cluster the right way, meaning using Terraform and fully automating and applying GitOps and doing some pipelines to do all this stuff. So when you want to do it in a more serious way, beyond playing around with it, then there are some complications. But I will, if I remember, and I am a forgetful person, so you need to remind me, I will post a link to, there are actually a set of articles, one for AWS, one for Azure, one for Google Cloud. Okay, so let's go now to my screen. This is my screen. I don't need Twitter account anymore. Cool. And let's start doing stuff. Let me move a bit. Okay, so I need Git repositories that define what is the desired state of my cluster. And I will have today two repositories here. One repository that defines preview environments. Those are the environments that will be created when I create pull requests. And those are the environments that will also delete, remove things when pull requests are closed. And I will have a second repository where my production cluster or segment of the cluster is defined. I want those two separate so that there is no confusion, that I can play with access rights and what's not. So let's get going. Let me go to this repository. This repository defines my desired state of my preview environments. And the file that matters here the most, remember I'm using Argo CD, and later on I will show you that I'm using Codefresh as well. This is what is defined over there. And that says, hey, I want to have an application. Now this is confusing because this will be what we call in Argo CD application of applications. And that means that think of this as, instead of saying application here, as if it says environment, right? The real term is application of applications. Anyways, it says, hey, this will be called previews. This is the repository that defines this cluster or segment of the cluster. Where whatever is specified in that repository is what should be running in the cluster. So think of this, that repository will be the desired state. And look for the directory Helm in that repository. And in that directory is that desired state. So it's not the whole repository, it's that directory. And then we have sync poll, and the namespace will be previews, but that's not really important. You will see soon later why. What matters is sync policy. It's saying, hey, no manual interaction whatsoever. Whenever it's fully automated, whenever somebody changes something in that repository, I want that to be applied to the cluster almost immediately. Self-heal means that if somebody makes manual changes to the cluster, as nobody should ever do that anyway, but if somebody does, then Argo CD should discard those changes and converge the state again. And prune being set to true means if somebody removes something from a repository, it should be removed. It should be pruned from the cluster as well. So it's full automation. So I will break my rule. And Tarin, if you're listening, if you can remove live, that would be great from the top. Okay. Kubectl apply. I'm going to create this. And I'm breaking my own rule. I said I'm not going to interact with the cluster directly. I will break this rule only once because it's going to be faster than if I do that through pipelines. But you need to trust me that you shouldn't do this manually in any case. And the file name is that apps file that I showed you before. So I created this resource, the custom resource definition in the cluster. It should be done by pipeline. It wasn't, doesn't matter. And from now on, Argo CD knows that whatever is in that repository is what should be running in the cluster. And that's it. Now I will simulate that I'm a developer. What that means that I will go to one of my applications. I will do the same things that every single developer is always doing, and we will observe how that affects the cluster. That repository is DevOps Toolkit. This is one of my demo applications. And I need to show you a few files. First file I need to show you is preview YAML. This file defines how should this application be running as a result of being deployed when somebody creates a pull request. This is Argo CD definition. And really what matters here is that it says, hey, this is the repository of my application. I'm intentionally keeping everything in almost everything in repositories of applications, because in this scenario, I'm assuming that all the truth about an application is in a repository of application, that people working on that application have full control over what's going on. So this will not contain the definition of the application. This is just a reference, only a reference to application itself. And it says, hey, when somebody works with this application, that application is stored in this Git repository. And then it says, but overwrite some default values. Do not use all the values that are set by default. And in my context, default is what will be running in production. Overwrite few things. This is the repository for the image. This is the tag that should be running. And this is the address through which this application is accessible. Now, few of those things are templated. And the reason for that is because tag will be changing all the time. And this address through which application is accessible will be changing all the time, because remember, I can have 1 or 0 or 1,000 pull requests of this application open at any given moment. So it is templated, and those things will be converted into real values at runtime through pipelines. You will see them soon. And the rest you already saw. It's fully automated, and sync option create namespace set to true, meaning that it should create a unique namespace for every single pull request. Okay, and another thing, before I go back to what I said before I start playing as if I'm a developer, one more thing I need to do is to show you the pipeline that will do this whole work. What I showed you right now is the Argo CD definition of this application. And this is Codefresh. Actually, let me put it down. Codefresh PR open, I think. Yes. So this is definition of the pipeline that will be executed, and you will see soon when. It's a bit long, but I will go fast through it. Just to give you a gist, this is not a tutorial or training about pipelines. This pipeline will be executed whenever a pull request is opened, reopened, or synchronized, meaning that updated. And then that's it. That's when it will be triggered. And then the pipeline itself has some steps. This one will clone the repository of application that will trigger a pipeline. This one will build the binaries of my application. This is a simple Hugo-based application. It just runs build sh script. This will build image. And you will notice that lots of those things are based on predefined steps. So in Codefresh, we have helper steps. You don't need to figure out how to build image. You just say, hey, run a step called build image. Here are the few arguments, and that's about it. Okay, question from Solkin. Or does Codefresh or Argo cover this ingress component? No, ingress component is a way in Kubernetes to enable external access to your applications. It could be something very simple like Nginx ingress, which is what I use today, or it could be some sort of service mesh like Istio or Linkerd. And I see here that you're mentioning Solkin Kong and HashiCorp. It could be Kong or HashiCorp. There are many different ways how to enable ingress in Kubernetes, and it really depends on which tool you use. We might come with a recommendation, let's say, which ones work better in certain scenarios, but ultimately it really depends on your application, definition of your application in Kubernetes. So here I'm building the image, and then I'm enriching the image. This is important because enriching image in Codefresh means that I'm going to let Codefresh know when I build the image, what is the pull request that triggered that action, what is the what are the git commits that triggered it, maybe what are the Jira issues associated. So we are enriching the image by providing additional information so that later on, when we observe what's going on, we can use that to our advantage. Then I'm cloning second repository. That's a repository that defines my cluster. In this case, the previews part of the cluster. I'm modifying the preview YAML that I showed you before so that the templated parts are converted into real values. And I will push the result of all that back to the repository. So this pipeline is not interacting with Kubernetes cluster in any form of way. And the only thing that I'm doing is building stuff, doing this and that, and then when it comes to deployment, I'm pushing a change to Git so that there is full traceability of what is going on. This pipeline is not going to deploy anything. It will push changes to Git, and then it will let Argo CD pull those changes and do the work. So not accessing the cluster in any form of way. I see that I'm getting some Slack notifications, so give me a second to turn off Slack. Okay, there we go. Okay, cool. So that's about it. Now, the only thing left for me is to create this pipeline, and then I can do the work of being a developer. And I like CLI's terminal, so I created that pipeline right now with this command Codefresh create pipeline. I did not set up anything in advance except to create a cluster. That's the only thing I did. Let me see that pipeline very quickly. Codefresh IO, just to double check whether something is missing. Here is the pipeline that I just created, PR open, and I think I might be missing. No, it's all good. So I created a pipeline. Here it is in Codefresh now, and soon it will start running some builds. And that just happened automatically, right? Now, let me go back to terminal and simulate that I'm a developer. Now I'm really doing what developers do. What is the first thing that any developer does when starting to work on a new feature? That developer will create a new branch, git checkout, new branch. I'm going to call it PR1, why not? I'm not creative today. And now I'm going to simulate that I'm making changes to the code. I will not really make changes to the code. I will make some silly changes to the README. I'm doing that just because I need some changes that I can apply to my repository. I'm simulating that I spend a full day writing code. So what is the next thing the developer does when finished working? Adding those changes to Git, committing those changes to Git, a silly change, and pushing those changes to the newly created branch. I always forget this, that I need to set upstream. Okay, and I push those changes to Git. So far, I haven't done anything that every single developer is not always doing. Now, the last thing I need to do that everybody does, I will create a new pull request. I already told you I'm freak about terminals, so I'm going to use a command to create a pull request. You can do it through GitHub UI. Repo is org, and what is repo? DevOps toolkit. And title is I do not have time to write a title. And the body is something. So I just created a pull request in my GitHub repository. This is the first pull request in this repository. I'm going to store that pull request number in a variable just for later. And now let's take a look at what is Codefresh doing. Let's see, where is that? Here. Oh, I might be in a wrong. No. Let's see what's going on. This is debugging on the go. What did I do wrong? What did I mess up? Did I mess up anything? Let's see. Triggers. Webhook, this seems to be working fine. Why doesn't it work? Oh my, this is now embarrassing. We see DevOps toolkit, that's a correct. Pull request open. Why didn't my build start? Let me check this now. I am embarrassed. DevOps paradox, DevOps toolkit. Here it is. My repo, settings, webhooks. Yeah, it was triggered a minute ago. Okay, let me check very quickly. You know, sometimes I use multiple accounts and I might be in a wrong account. No. That's not the one. Oh my. Okay, let's try again. Git checkout master, git checkout -b new PR. Making some changes. Okay, git add, git commit -m git push. Okay. And create a pull request. New PR, okay. Let's see whether it works. Yes, I don't know why it didn't work the first time. Call it whatever you want. It works the second time. I'm not sure why it didn't. Anyways, question from Daniel while waiting for the pipeline to execute. And the best time to ask questions is when waiting for the pipeline to execute. To be clear, are we looking at Argo CD, CI/CD pipeline definition, or Codefresh 1? We are looking at both. So Codefresh, Argo CD is not doing CD. It's a horrible, terrible name. Argo CD is doing only the deployments of stuff based on definitions in Git. But for us to have those deployments, we need to build binaries, build container images, change those definitions in Git, and so on and so forth. So Codefresh, we are looking right now at Codefresh pipeline that does the whole lifecycle, CDI lifecycle. And the deployment part is done by Argo CD. Because at the last step, this pipeline will be pushing some changes to Git, and Argo CD will discover. Now, to be even more precise, Argo CD, that's what we've been working on, and there will be a huge announcement next week about that in more detail, that we are integrating with Argo CD, and Argo CD is a very important component in Codefresh. But it's one of the components and only in charge of deployments. And while I was talking, this pipeline just finished. It built the binaries, it built container image, and it retrieved the information about preview environments and pushed the changes, changes by saying, hey, somebody wants to run this pull request. Okay, going back to the terminal. Export PR number, I will need it for later, is 2. Okay. Now going back to the terminal, if we go now to Argo CD, which is here, what we see here is, let me make this bigger. This is the first application we are deploying, and there is a preview environment here, and this was just deployed a few moments ago. This is the result of me creating a pull request. The application associated with that pull request is running inside of my cluster, and I can go there and see these are all the components of my application. Kubernetes, it's complex. There is a service, deployment, ingress, endpoints, replica sets, pods, and all that stuff. But that's not the subject today. What matters is that I created a pull request. That's the only thing I did. And the result of that is that I have a new pre-release, let's say, running in my cluster in a unique environment, and I could create another pull request, and I would have 2 and 3 and 4 and 5, all of them running in parallel. Now, if I go back to the terminal, kubectl get namespaces, you will see that this was created. Where is it? This is a namespace dedicated to this pull request. PR DevOps Toolkit, name of the application 2, because it's a pull request number 2. What else? Quickly. Yes, and if I do kubectl-n, let me copy and paste this, get pods, you will see that my application is running. This is my application that is running because I made a change in Git, and I made that change by creating a pull request, which triggered the pipeline that made that change. Okay, and the last thing I'm going to show you now about this is, where am I? I got lost in what I wanted to do. Yes, let me confirm that my application is really running. Kubectl-n, kubectl get ns, kubectl get ns, and kubectl get ingress, all ingresses in a cluster. This, where is it now? This is the host. Let me put this up above my head. This is a temporary address created for this application. It is unique because it consists of a PR, name of the application 2, and then the address of my host. And if I open this in browser, you will see my application up and running. And all I did was create a pull request. Cool. Now, let's go back to the terminal. And I'm going to go back to the master branch. Okay, git checkout master. And I'm going to show you yet another pipeline because it is important. Cut, Codefresh, PR, close. Now, what this pipeline is doing, this is the second pipeline that we are using. This will be the pipeline that will be executed whenever somebody closes a pull request. As said before, that I don't want to keep those applications running longer than necessary. So I want them to exist only until somebody closes a pull request or merges that pull request to the master branch. So when it's closed, this pipeline will be running. And what this pipeline will do, again, it will not go to the cluster and do delete application. It will clone that same repository that defines my application. It will remove that file from the local repo, and it will push a change to Git. So just communicating with Git, nothing else. So let me create that pipeline. Codefresh, Codefresh, create pipeline, -f, Codefresh, PR, close. And now, if I go back to my pull request, do I have it open? Yes, this is my repository. Remember, this is the pull. Actually, let me first show you one more repo that might be interesting. Argo CD previews. This is the repository that defines my cluster, my preview environment. And there is a templates directory. And you see here this file was created by the pipeline. This says, hey, somebody wants to run this application. If I would create second, third, fourth, fifth, 10th pull request, pipeline would keep adding files here. And I always know that what is running in my cluster just by exploring this directory, repository. Question from John. Does this workflow support deployments of many applications from a single monorepo? Yes, it absolutely does. I'm using 2 repositories for environments, previews, and production today, but exactly the same would happen if you use monorepo. And the reason why it would be exactly the same is because Codefresh pipelines, 2 things. First, Argo CD, we tell Argo CD, hey, this is defined in this repository and this directory. So if you have monorepo, you can say this repository and directory A for this repository directory B for that. Codefresh, on the other hand, is designed with monorepo, among other things, in mind. So when we create those triggers, like the one I did, let me actually show you this very quickly. If this is my pipeline, if I go to my triggers, if I show you this one, I could say, hey, this should trigger only if, where is it? If, for example, the change was from a directory production. And then some other pipeline should be triggered if a directory in that monorepo is something else. Cool. Keep interrupting me. This is great. I like questions. That's more interesting than me talking alone. Anyways, what am I going to do now? I created a pipeline. Yes, I did that. That was the last thing I did. So I'm going to go to my pull request. You might be bored from terminal, so let me do it from a UI now for a change. This is the pull request I created. This is the one. This is the pull request I created. You can see here the pipeline that was executed. And I will say, hey, close this pull request. I don't want it anymore. This is horrible. You shouldn't have done this, right? And this will trigger a pipeline. Where are my builds? Here's the pipeline that will make the change to the Git repo. Now let me be fast. Observe now, this is the repository where it says, hey, somebody would like to run this application. Soon that file will be gone. I'll get back to it. Let's see the pipelines again. Still running. It is removing the file right now in front of our very eyes. And it is removing that file. And the question, excellent, from Vadim. Vadim, good to see you again. As a security aside, is Argos pulling desired state any better than Helm upgrade directly from pipeline? So if you put security aside, that in this case you don't need access to the cluster, another thing that comes to my mind that Argo CD does is that it is monitoring your Git repo all the time. So if I go now and actually, I'm going to show you one more difference, Vadim, in a minute or two. In 3 minutes, 4 top. Here is the repository. You can see that the file is gone now. Pipeline changed the desired state stored in Git. Now, if I go back to the pull request and reopen it, you already know what will happen. This will trigger a pipeline, which will actually, if I go now to Argo CD, you can see that the application is gone from here as well. And here soon I will have a new pipeline running. Here we are. That will do the same thing as when I created the pull request. It will redefine the Git repository. Now, when this is finished, I will show you, Vadim, one of the things that Argo CD does that Helm doesn't. And until I am able to show you, one thing important too is that Argo CD is continuously monitoring Git repositories and making sure that the actual state is the same as the desired. Helm is not doing that. What I mean by that is, apart from doing equivalent as Helm upgrades, Helm install, but without having access to the cluster, it monitors the state all the time. So Helm is one-time deal, let's say as a result of pushing something to Git, while Argo CD is monitoring the state all the time and converging whenever there is any discrepancy. And I will show you that in a second. Let's see whether it is running. I should have the pods running in a second or two. Where is it? Here. Right now it is not running. Sometimes it takes, it can take up, I set up Argo CD to take up to 30 seconds between synchronizations. So it might take a moment or two. Here it is, it's running. Now, going back to Vadim's question, I have a deployment here. And let's say that I'm an evil person who doesn't know that those things shouldn't be done. Let's say that I delete deployment from the cluster. I'm not now making any changes to Git. I'm doing what evil people do, interacting with the cluster directly. So I deleted deployment. Now, if I output the pods are not, it's already running. Argo CD already detected that there is a discrepancy between what I'm doing and what is defining it. Even though I deleted it from the cluster, Argo CD regenerated the deployment. Actually, here it is, deployment. It was created again 30 seconds ago. So think of Argo CD in a simplified way as doing Helm upgrade all the time. Actually, not all the time, but whenever there is a discrepancy between what is defining it and what is the actual state. So let's try, I might be able actually to make it on time. I almost never make it on time. Let's do one more thing, one very important thing. How do we do all this in production? And to do that, there is one thing missing. I'm going to go one directory back. I'm going to the directory that defines my production. This is repository that defines my production. And going back to the John's question, it could be same repository, it could be monorepo, doesn't really matter. I'm going to show you the applications file, apps YAML. This says same as before. Argo CD, this is the production repository. Argo CD should monitor this repo as well. This is the directory, and so on and so forth. Do whatever is defined there. I'm not overwriting values because in my case, production is default values are always production. So right now in this repository, I have these files in this repo. Sorry, wrong command. In this repository, I have two files that define two applications that should be running in production, DevOps Paradox and DevOps Toolkit. So I will tell Argo CD the existence of that repository by applying this definition. And remember, this definition is just a reference to a Git repository. And you already probably can guess what is happening, what is going to happen. Let's go to, where are we? Let's go to Argo CD and see. Oh, actually it happened just now. It right now, it detected maybe a few seconds ago that there is a new application called production. That production references a Git repository. It has those two applications defined, and they are already there running. It already synchronized, and you can see it here. This is a production version of this application, and there is a second application, DevOps Paradox, also running there. All I did is push a change to Git. Actually, it didn't even push a change to Git. I just told Argo that there is a Git repository. Now, we're almost done. What I'm going to do, one more thing that I'm going to show you is go back to the repository of the application, DevOps Toolkit. I'm going to go to the master branch, just in case. And I'm going to show you one more file. And this is cat Codefresh PR merge. This is the pipeline that will be executed when I merge something to production. And what it will do is slightly different this time. Building the application, cloning the repo, all that stuff. Actually, am I in the right file? Yes. What matters is that it will end up creating a pull request. And that pull request will contain changes, suggested changes that should be applied to production. And we're going to do that right away. We're creating the pipeline. And I'm going to go now to the repository of my application. Is it this one? No. Is it this one? Is it this one? Yes. This is the pull request, still the same. I'm going to say, yes, I want to merge it. I'm going to merge this pull request to the master branch. And that, as you can guess, should trigger yet another pipeline. Two pipelines. One, because merge is the same as closing. So one that will remove the temporary preview environment because we don't need it. I just merged the pull request. And the other one that will modify the repository that defines production. They should be finished soon, hopefully. Okay, one is running. Both of them should be running. The one that I'm really interested in is this one that will create changes to the production repository. And while happening that, waiting for that, I'm going to open it, that repository, Argo CD production. And I'm going to go to the pull requests. You'll see soon why. Come on, almost there. Almost there. Creating a pull request. Still not interacting with the cluster directly in any formal way. Here we are. And where is my production? Here, production, refresh. Here is the pull request. Why isn't it yet created? I forgot to do something. I'm not sure what did I forget. It created a branch, but it forgot to create a pull request. I probably messed up the pipeline. I will create the pull request myself. What matters is here the files changed. And what matters, ignore this. This is all formatting, right? What really matters here is this guy over here. This is the only change that matters. Ignore everything else. What this pull request is doing is saying, hey, in production, you're currently running the latest tag. You should never be doing that, but you're doing it anyway. Now, I want you to run this tag. This is the new tag that I want to run in production. The rest is only cosmetic, you can ignore. It changed the tag to match the new build that was created when we created the pull request. And now, I could have done this without a pull request. I could have changed production automatically when I merged, and then I would be doing continuous deployment. But I'm not doing that. I want to show you continuous delivery and assume that there is a manager in your company who wants to approve changes to production. So if you're that manager, you would go to file changes. You would say, okay, so this is what somebody wants to change in production. I agree. I think that that's a good thing. We already passed the test and everything. I'm going to merge this change to the production repository. And this will not trigger. This is the only time we are not triggering any. I'm not triggering any pipeline. I don't need a pipeline for this. If I would be running tests, then maybe I would have a pipeline, but I don't need a pipeline for this. In this case, pipeline created this pull request, and I merged that pull request as showing my intention that I approve it, and now Argo CD will converge. And we can, if we go back to Argo CD, let's see what is happening. This is my application running in production. It succeeded. Last time it synchronized 6 minutes ago, and now soon it will synchronize again. Every 30 seconds, if I'm not mistaken. I have too many tabs open. Did I merge it? Yes. Okay, while waiting, Filip Božić, if we are not interacting with Kubernetes from pipeline, can Argo run tests and notify pipeline back with results? No. Argo only does deployments. For running tests, you need a pipeline. Like the pipelines I'm using, even though I'm not having tests, but it will be just another step in a pipeline. So when you think of Argo CD, and I repeat, having CD word in the name is horrible. It's not really doing continuous delivery. It is doing only the deployments by monitoring Git repositories. Everything else done through pipelines. I hope that answers your question, Philip. I'm not sure why this synchronization did not happen yet. What did I forget? Let me check what is my, how does my production look like right now? Templates. DevOps toolkit. It should say the new tag. Yes, that seems to be okay. Why didn't Argo CD synchronize? Or maybe it did. Let's take a look. Let's take a look. How can we take a look? kubectl -n production describe deployment DevOps toolkit, and let's see whether it modified the tag. No? It's not product, it's production. Where is the image? Oh, okay, so I probably messed up something by trying to be on time and go very fast. So I'm going to synchronize manually. Imagine that I didn't do that, that I synchronized automatically. And then it should work. No, not yet. I forgot to do something. I'm not sure kubectl get applications. What did I forget? Dash a dash n argo cd describe application production. I probably made a mistake. Let me see what is the mistake. Let me see what is the mistake. I made a mistake. Imagine that it worked and I had a new release running in production. I'm just going too fast. I was silly to put too much material into 1 hour. If I go back and fix whatever I forgot to do, it would be running in production. Now, we have 3 minutes for questions, but I can stay longer, so we can have probably more than those 3 minutes. If you have any questions, please let me know, and I will do my best to answer them, whatever the questions are. Remember, next week, big announcements about integration, about GitOps and Codefresh. So watch our site or YouTube or whatever. You'll figure it out for the announcements we're going to make. And your comments, questions, anything. You're a complicated crowd. I'm going to give you 15 seconds more for questions or comments because they're sometimes delayed from coming from YouTube to StreamYard, from where we are streaming. And if there are no any questions, remember, subscribe to the YouTube channel if you want to see more. And live happily ever after, I guess. Okay. Oh, this is a message. Yes, thank you everybody for joining. I think that's it. Did I go too fast? Put that in a comment. Victor was going too fast. I probably was going too fast. If I was, I will be slower next time, I promise. Okay. Eduardo, what are people using for updating with Git when a new image version is built? Custom scripts? In this case today, I'm doing that through pipelines. Codefresh integration with Argo CD, with Git and all that stuff. Today I'm doing that. So I'm not going to say that Codefresh is the only way to do it, but that's my preferable way. Or let's put it in a more general term. You will have pipelines that do this and that when you make changes to Git. And one of the things that those pipelines should be doing, one of the things that they shouldn't be doing is executing ad hoc random commands in your clusters. One of the things that pipelines should be doing is modifying Git repositories. And really depends on which exact, there are a couple of good ways to do GitOps related to deployments at least. And it really depends which process you choose. Like I'm today presented the process of creating temporary environments based on pull requests and assuming that merging pull requests of an application to production should create a pull request in the production repository and so on and so forth. So short answer, pipelines. I have a question from one more from Solkin. I subbed the channel and will be using Codefresh on my stream when I do live coding. That's awesome. That's absolutely awesome, Solkin. Hey, ping me if there is anything I can do to help. Anything. Advice, material, joining your channel, whatever you need. Papa says, tool do you recommend that can deploy 100 apps to a Kubernetes cluster? I haven't found the limit yet of Argo CD for deploying apps to your cluster. 100 is a very, very small number. It sounds like a lot, but it's small. I can suspect, which I didn't test it yet, that it might start crashing on tens of thousands or something like that. But 100 apps, yeah, absolutely no problem at all, Papa. From Bavin, and if I butcher your names, that's not on purpose. Sorry for that. Bavin says, can we use GitOps concept to build Terraform and EKS? Yes, absolutely yes. I did that earlier before this session because it took like 15 minutes to create a fully operational cluster. Yeah, the logic is, so what I was doing, and if I remember, I will put the link to the article in the comment section later of this video. What I do is that I have a repository defines my cluster, like the ones I showed you. It has a section for applications and it has a section for infrastructure. And I would be pushing changes to my Terraform definitions. And then when I create a pull request, pipeline would execute Terraform plan and send the results of the changes that Terraform would do to the comments of the pull request. And then when I merge those changes to Terraform definitions, after taking a look at the result output of the plan, a different pipeline would be triggered that would apply those changes, execute basically equivalent of Terraform apply. So yeah, and there are 3 articles, Bhavin, and one of them is based on exclusively on doing that with EKS. Thank you so much for coming. I hope that this sparked interest in GitOps, Codefresh, pipelines, Argo CD. Contact me directly, contact me through Codefresh. Go to Codefresh.io. See you next time. Cheers.